In just hours, NASA will attempt an air launch on our Space Coast, sending a Pegasus XL rocket equipped with a satellite called the Ionospheric Connection Explorer, also known as ICON.
The mission will study the dynamic region of the Earth's upper atmosphere, home to colorful auroras, communication satellites, and humans aboard the International Space Station.
But before its launch, we get to learn more about ICON and the ever-changing conditions in space, known as space weather. So joining us now is NASA scientist Jeff Klenzing. Good morning, Jeff. Thank you so much for joining us.
Good morning.
All right, so you have to give me an idea of what can this look like. We're talking about 30-something thousand feet above the surface, and this is all going to be airdropped later on tonight?
Oh, that's right. So it's a Pegasus XL launch, so it's going to be basically strapped to the bottom of a jet, taken out over the Atlantic, and launched from there.
So is this something that people will be able to see if they're along the Space Coast, or will it just look like an aircraft just lifting off like a normal airplane?
Probably, yeah, it would normally look like just a aircraft launching, I think.
All right, so the ICON will see some beautiful bright swaths of red and green lights in the atmosphere. We have auroras. Kind of give us an idea of what all this colorful glow is all about.
All right, so mainly we're going to be looking at the air glow. It's kind of bright lights, kind of like aurora, but it's seen at much lower latitudes. And it's seen everywhere, actually. But this is sort of bright red and green images that you can see, some images from the space station right now. And basically, as the sun is dumping energy into the atmosphere, it's exciting the atoms and molecules. They're emitting red and green lights. ICON is going to look at those lights in order to better understand the ionosphere and the winds and temperatures that are driving all of these effects.
All right, so of course we have to pay attention to the weather down at the surface for launches, but you guys also have to look at the space weather as well. How is the space weather looking like for today's launch?
Space weather is looking pretty quiet right now.
Well, that's good. And how does the space weather actually affect us down at the surface?
So one of the ways it can affect us is it can interfere with communication and navigation signals. And so if you think about GPS, navigation for airplanes, for self-driving cars, things like that.
Yeah, and we're talking about the GPS and the different satellites up in the sky as well, but it's also useful to know for folks going up there for the ISS as well, correct?
That's right. So the ISS is basically right where the ionosphere is. You can see from the images the astronauts are taking. This is also useful for if we're sending astronauts back to the moon or beyond, right? Because we need to communicate with them, as well as just once you leave the Earth's magnetic field, you're in a much harsher radiation environment and you're more prone to CMEs and things coming off of the sun.
And we're talking about how far off the Earth's surface are we talking about all these different colors in space, and when does the surface weather change to space weather?
So the ionosphere is actually kind of the transition between Earth weather and space weather. It's about 200 to 300 miles off the ground. And so what ICON will be looking at is not just the space weather that's driven by the sun, but that which is driven by the Earth. So winds down in the lower atmosphere can be driving electric fields that propagate up.
Oh, wow. So everything is all connected. I'm just glad that as a meteorologist here down at the
That's
surface,
right.
You guys can take care of the stuff further up there in the ionosphere. Well, thank you so much for joining us. And of course, we're keeping our fingers crossed that everything goes off without hitch today. Thanks, Jeff.
Thank you.